All right. So I'm just gonna get into it, and then VOD. We can always like watch the VOD. Whoops. So let's do a recap of last time. Last time we talked about. We did sort of a discussion overall about getting started, and we talked more about the basics of variables and what they are. We discussed kind of how to do naming for the variables, so that was kind of an important aspect. We talked about snake case versus camel case, just the right way to name your variables. It's pretty important because you're going to be making a lot of variables or creating a lot of variables within your scripts or within your modules. So knowing how to name it is pretty useful and important, and also making sure that you just don't name your variables like random stuff, which you can if you want to. You can name them like, you can name it X or A or B or my name or whatever. But what's important is the data that the variable points to is irrelevant unless the programmer or whoever's looking at your code understands what that variable does or how it's used. So having a name that kind of references what the variable is pretty important. We talked about type conversions. So we talked about how we can take the basic data types like strings or floats or ints and convert them to different data types and why that's useful. So we saw how we can take certain data types, and when you do math with, say, ints versus with floats, you're going to get a different answer. So it's important sometimes to do type conversion in order to convert the data into a type that you can use. We talked about the input Python function, which allows you to take user input. So you can call input and ask for something. Like if you want to ask the user for specific data, you can take it and then the user can type it in and then run it. We also discussed the basics of functions. So we talked about what a function is. We talked about why it's useful. And we'll recap the end of that in this session. And we just did a little kind of example on calculating sales tax. So just a basic example of how you can use that. So let's recap functions. So remember last time we talked about functions and how functions are a pretty foundational part of programming, not just Python, but programming. And a function itself is a chunk of code that performs a specific action. So you can create a function and put some code in it, and it allows you to sort of create reusable code that can be used throughout your script or throughout the rest of your code. And we talked a little bit about how to create it. So you have this Python keyword def or define, and then you have, similar to a variable, you have to name it. So you want something useful. In this case, obviously, we just use name a function, but you can say, like in our previous example, we had calculate sales tax as a function. It can also take optional parameters, which are basically inputs to that function. So a good example for that is when we did our calculate sales tax, we wanted to be able to provide the subtotal amount as well as like the sales tax that you're looking to add on to that amount. So those are your inputs. And then anything within the function has to be tabbed in. So in Python, before I say that, then you have this colon, which is also really important because it tells Python that you're looking to create this function and that everything below it that's tabbed in is going to be part of that function. It's that block of code. So remember, Python is reliant on spaces or tabs to define what's a function and how it should essentially go through the code. So this block code, anything that's tabbed in here is going to be a part of it. And I'll kind of go back to my example and discuss it. So let's actually go back to, let's see here. Let's go back here. Okay. kind of move this. So if we go back here, we talked a little bit about creating the functions. So we have a very, very dummy example here. So we have this print hello world, which is a very, very, dummy example. But you can see that this line of code in here is part of that function. Same thing with this calculate sales tax. These two things are part of that function. So those things are within the function. And when we call it, we can call it like this, calculate sales tax. And remember up here, we asked for a subtotal as well as the state tax. And then we ran the calculation. And then we use this return keyword to basically say that this function is going to give an output. So if I go back here, I can say total equals this. Because I'm returning a value back, this value is going to go in here as a variable, which is useful. Let's see here. So one thing that I quickly wanted to discuss is we've been using the Python interpreter like this to do all our dummy examples for the code. So in our past 2 live streams, we basically talked about running commands in here, right? So like print hello world to run the commands. Whoops. Print hello world to run the command. So that's all well and good, but the problem with this is when I exit out of this by calling the exit function and go back in, actually I should actually store something. So if I store a variable, right, I can call that variable and it's going to tell me what that variable is. But if I exit and then I go back in, that variable is no longer there. Same thing with the function. If I call this print, I can say def print hello world. And then I create that function. I can call it print hello world here, and it's gonna do whatever code, it's gonna perform, or it's gonna run whatever code is in that function. However, if I exit out of this, it's gonna be gone, right? Now, what's cool about Python is we can store all this in a specific file. So we can store this in a folder, and we can create files that are Python specific that we can then reuse within Python, the interpreter. And I'm gonna kind of explain that. So on my desktop, I just created a folder called Learn Python. It's just a folder on the desktop, and I created this test file with the extension .py. So that .py tells Windows that this is a Python file. And this is the test function that, or the test file that I have here. And it's pretty much just like a text file, right? It's just like a text file. We did end it with the .py so it knows a little bit more, right? If I save that out, and if you go to your command line on Windows or the terminal on your Mac or whatever, let me reopen the command. So what I can do is if you're doing this on the command prompt, then you can basically take this folder, drag it in, but make sure you hit a CD space this folder. That's going to take your command prompt to that actual folder. And if I run Python on this file, I think this should work. There we go, yeah. So what I can do now is I can import the file that I had called test. Now remember, you have to be in the folder on your command line, and we'll talk more about how you don't need to be on it, but for now you do need to be on it. Just saying that for now. And I'm just showing you this now because that way we can start like saving files out that have the code that we've been typing instead of just doing it in the interpreter, because it won't be saved. So just to show you again, there we go. So I just ran the command line, and if you don't remember how to run the command line, you can type in the Windows bar, just search CMD, and then it'll pull up the command prompt program, and it should look something like this. Again, the command prompt on Windows is just like a terminal that you can use to access your files, and you can basically run stuff in a terminal-like interface for Windows. On the Mac, you'd be using the terminal. Same thing on Linux, you'd be using the terminal. Now, I'm not in the right directory, so I can do CD space, drag this folder in to drag the file path of where my actual files are, and hit enter. And if you notice on my Visual Studio Code, I'm already in that directory, so that's already there. So if I type Python again, and I import test, what's going to happen is it's going to take all this code and it's going to import anything that it has in there. Now, by importing it, I can type print hello world. Oh, excuse me. I can say test.print hello world. And I have to provide it a name, so so if you look at this first error, it still doesn't have anything called print hello world. That's because it's tied to the test module here. So I had to type test.print hello world. So I should probably explain that. I'll hold off on this a little bit, because I think I'm going to save that for another time, because I need to actually go more in depth with that. Let's go back to our notes real quick. So I just kind of wanted to explain functions. I kind of got ahead of myself, but okay. So we talked about last time about functions. We also talked about how print and input themselves are functions. Those are special Python functions that exist already in the Python world that we can use. So those are functions on their own. And you notice the syntax is very similar. We have the name of the function, in which case is print or input. And we provided it some input. So for the print, we provided it like a string, like the statement that we were going to print out. And same thing with input is we provided another input or parameter, which was what did we want to print out to provide the input. So going back, this is our example of the calculate sales tax that I showed you. And so we created the function here, right? That's where we created the function. However, this code doesn't get run yet. How it gets run is we call it like this. So we create a variable called total, and then we can store, or we can call the function here. So this will actually, by calling it here, it will run this, provide the output using the return keyword, and then store it in this variable. And then that's how it runs the actual code. All right. So I'll go back into, actually, let's go into modules now. I say screw it. Let's go into modules now. All right. Okay, let's go into modules. So I'm just gonna hit enter a bunch of times just to clear all that. Do clear, right? Okay. All right, let's go back and talk a little bit about how to use modules. So like I said, we have a test file that we created, so test.py. We filled it with some code, in which case we have two functions here. And in our terminal, we made sure to be in that directory that has our file. So now, if we go back into Python, we're going to use this keyword import. So I'm going to kind of reiterate all this and kind of explain how this is. So by calling this import keyword, this is a specific Python keyword that basically tells Python, there's firefighters outside, it's super loud. By using this import, we're basically saying to Python that we want to import a specific module to use within our code. Now, this is used more than just throughout Python. It's used throughout other programming languages. Sometimes it's different, it's worded differently. But the reason you want to have modules is you can then organize your code in a very specific way that allows you to sort of put all the functionality for a specific code base in sets of files. And by having this namespace, it makes it easier for you as a coder to understand how to access certain things that can do other things. A good example would be if you were creating some code to authenticate users, you would probably want to have some type of library that's like an authentication library. Or if you were doing something that had very specific functionality or that performed very specific math that you needed, you can create something like a math library. Python itself actually has what's called the standard library, which includes a bunch of stuff, so we don't have to like code every single thing to do something. We can import what Python provides us and use that to help us, which is really cool. But I'll talk more about that later. So in this case, Python, since we're in the directory learn Python, let me get that file back up. So we're in the directory learn Python here, and there's the file test.py. So it knows that test is a module. So I can say import test. Now to access the functions from here, I can say test dot print hello world. And since my hello world requires an input, I can put my name Monk, and it will run this code here. Pretty cool, right? So it basically, we can write a bunch of code, functions and stuff, and we can go back in here and then run those pieces of code. So that's really nice. Now, the reason we had to call test dot is because we imported the test module. Now, another thing we can do is if we don't want to have to say test dot, I can say from, what was it? Let me see. Let me remember the exact syntax. I can use the from keyword, so I can say from test import a specific, and this is where it gets really cool. I can import a specific function if I want to, in which case if I just needed this calculate sales tax function and I didn't need this print hello world function, I can import just this, and I can just say calculate sales tax, like that. Now, by doing this, I can go back in, and now I can say calculate sales tax, and I can give it a subtotal, so say 19.0, and a state tax, say 1.095, and run it, and it's gonna actually go in and run my code here. And if I try to run print hello world, again, it's not going to work because it doesn't have context of that yet. But say I want to just get everything from this particular module. The other way we can do this is we can say from test import star, which means just import everything in this file into our interpreter right now. So those are a few ways that we can import these modules and run the actual code. I'll go more in depth with modules later on. I just wanted to give you the like bare bones basic for now, because yeah, I don't want to go like super in depth because we're not gonna like do examples of all this stuff quite yet. All right, so let's kind of go back to our other screen. All right. So let's talk about one of the data types that I discussed earlier, which is Booleans. Now, we kind of went in depth and we talked about integers and we talked about floats and we talked about strings, but we haven't really talked too much about Booleans. And Booleans are quite important. I mean, they're super important. So we talked very briefly about Booleans, and I mentioned that they were basically, it just represents true or false. But let's kind of take a look at that more in depth. Okay. So just clear that screen out, and kind of move this up. Just clear that out. Okay. So we can create a variable and define that variable as true or false. So I can say I'm cool is my variable name, and I can remember you have to have a capital T or a capital F for like true or false. So I can say I'm cool equals true, and if I type I'm cool, Python's gonna see that is true. Also, if I use the type of I'm cool, you're gonna see that it's a class Boolean. So we know that that's a Boolean type. But saying something is true or false is pretty like, there's no point in that really. So there's another thing that I want to talk about, which is essentially expressions and Boolean expressions. So let me go back to my notes. Okay. So there's a couple of specific operators we use which will create a Boolean value. So we have this x equals y. So you'll notice that there's two equals here, not just one. When we used one equals, that meant that we were creating or assigning a variable, right? So double equals is a comparison operator. And what this comparison operator means is if this value of x is equal to y, then this expression itself is going to be true. Otherwise, it's going to be false. Now, I'll get into the rest of these ones in 1 second. We'll go ahead and go back to just the interpreter real quick. So if I, instead of saying x and y, say 1 is equal to 1, this expression itself, by hitting enter, is going to give me a true value. So I'm not creating a variable like up here. I'm just running a Boolean expression to see whether this is true or false. Now, what happens if I type 1 equals to 2? This is going to give me a false value because obviously 1 is not equal to 2. So going back to our notes, you can see that there's a couple of other operators we can use. We have this exclamation equals, which is not equals. We have a less than. We have a less than or equal to. We have a greater than, and we have a greater than or equal to. So you've probably seen some of this in math. You know, it's very simple sort of math operators. So if we go back to our expression here, if I type 1 exclamation point equals 2, what do you think the value is going to be? It's going to be true because I am saying 1 does not equal to 2, which is a true statement. And if I do this 1 does not equal to 1, it's going to give me a false. Or Similarly, I could say 1 is less than 2, which will give me a true value. Now remember, this reads left to right. And so we can say 2 is less than 0, which is a false value. So you can see how all these expressions work. They all produce a Boolean value of true or false. So I can do something here. Let me just exit out of this, clear it, and then I'll run Python again. So let's import our calculate sales. Let's rename this. So I'm just going to get rid of this stuff right here. So I have this function. And let's rename this to calculate total, because this is actually a total, not calculating the sales tax. Okay. So I'm going to do that same import that I did previously. Go from test, import, calculate, total. And I've imported this function. Now, say I have a variable called like money in account, which is going to represent how much money I have in my bank account. So I'm gonna define a couple of variables that we can use to see how Boolean expressions work. So I'm gonna create, say I have a subtotal, and you can see how this example can sort of apply to just being useful in some way, right? Even though this is a very basic example. Say I have a subtotal of $98, right? That's my subtotal. And since I live in Cali, the tax is equal to 1.095. And I want to know if the total is going to be more than the money I have in my account. So say the money I have in my account is 102, right? Now, obviously, if you're really good mathematically, you'll know what the value is, or if you have enough money in your account. But let's just say, for instance, we built some program that is sort of an e-commerce thing, and it's supposed to be able to check the subtotal or get the total, and it represents, you have to get a sales tax for the specific state, and you need to check to see whether they have enough money. Super basic example, but you can see how it applies to real world. Now, I can get my total, so I can say total equals calculate total, and I got to provide it the subtotal, as well as Cali. Oh, I called it Cali total. I'll just. So I named this variable wrong. It was supposed to be called Cali tax, but I call it Cali total. But we can still use it since we created it. All right. So I'm going to call this function calculate total, and it's going to take this subtotal and this Cali tax, which I named wrong, and calculate the total for me, right? Now, without even looking at what the total is, I don't, as a computer, it's not going to computers don't have that, mentality to just understand whether something is or is not greater than. But what we can do is I can create a new variable called has enough money, and I can say is equal to money in account is greater than or equal to the total. Now this statement right here, what this is doing is this is the Boolean expression we have. We're saying, does the money in our account, do we have more or equal to the total amount? And we're going to store it in this variable has enough money. So I've hit enter. Now I can print has enough money, and we're going to see that we're going to get a false value back, which means that we don't have enough money in our account. Okay. So this is essentially a Boolean expression right here. Now, another thing we can do is we can sort of make our Boolean expressions more complex. So if we go back to the notes. Now, these are what's called logical Boolean operations. And there are a couple of, again, Python keywords that are used to help combine Boolean expressions in a very specific way. And let's go through those. So we have this OR operation, which basically means if either X or Y is true, then this expression itself, or this operation, is true. If both of these are false, then it's false. Now, what does that mean? It means if this Boolean expression X is this a true value? If it is false, then you're basically saying, okay, that's fine. Y, let's check to see if Y is true. And if Y is true, then we can continue doing something. So we have X and Y. And if you sort of just think about like talking about this, say instead of saying X, we say, let me think of a right way to say this. Like, we can even just say X is the sky is blue, right? If the sky is blue or the ocean is blue, then we have a true statement. But even if we said the sky is purple or the ocean is blue, then you can see that now you're saying, well, the sky obviously is not green, so it's not true, but you just said or the ocean is blue. Okay, so that whole statement I just said is valid, it's true. However, with the and, you're basically saying that both expressions must be true in order for this whole operation to be true. Because if I said the sky is green and the ocean is blue, that's obviously false. But if I said the ocean is blue and the sky is blue, then that will return a true value. And then the last one is not. So this kind of makes me think of like the whole Borat scene where he's like, this suit is not black. And it's pretty much just saying that this is the opposite of whatever X is. So if you're saying the sky is green is a false statement. But I'm saying not, so then that makes it true. And we'll go more in depth with this and discuss everything, like show examples of how that sort of works. So we can go back to our example. So let's go back to our example. Okay. So we made this variable has enough money, and we check to see if the money in an account is greater than or equal to the total, right? But what if we had a second account to check? So I can create a new variable, money in second account, and let's say this is 110, right? I don't know what the total is right now because I didn't check it, but if I say it's 110, now what I can do is I have two accounts and I want to check both of them, right? So now what I can do is I can say has enough money. I can reassign this variable is equal to money in account is greater than or equal to the total. And now I can use this or statement, money in second account is greater than or equal to the total. So now what I'm doing is I have two Boolean expressions. I have this one right here, money in account is greater than or equal to the total, or money in the second account is greater than or equal to the total. So if we look back here, you can see X or Y, right? So you can assume that this right here is our X expression, because this right here is going to produce a true or false value. Or our Y expression. So money in second account is greater than or equal to the total. Now, if I run this and I print has enough money again, remember previously when we only checked the first account, it had a false. So now I'm getting back a true value. So if I print the total value, you can see how much the actual total was. So the total was $107.31. So we know that our second variable, this money in second account, had enough money in there for this total. So here, the money in account is greater than or equal to total. We knew that was false. We did it up here. We knew that was a false value. But it was false, or money in second account is greater than or equal to total, which is true, which gave us this true value back. Or if we wanted to see if both accounts had enough money to pay off that total, we could go back to this, and instead of saying or, I can say and if I print has enough money, you'll see that now it's false because we didn't have enough money in our first account. We did have enough money in our second account, but we use this keyword and. So that's another keynote on that. Or we can say print not has enough money as a keyword, and you can see it gives me now the opposite. So we talked about Boolean types, that they're true and false. And we talked about how to compare them, right? How to do comparisons to get those Boolean types. And then we also kind of did these Boolean operations to create more complex operations. But we still didn't really talk about how this can be useful in our code, right? I created these variables here, but I really haven't done anything that special. I've just checked to see whether we had enough money, and we just got a variable back. So I want to talk about conditionals. And conditionals are another very key part in programming, not just Python, in all of programming. And conditionals are basically a way to run certain blocks of code if certain conditions are met, and potentially run other blocks of code if they are not met. And that's really important because a program doesn't just, well, it can, but you don't want your program to just run every line down the chain and it just does something. In most cases, most programs have some sort of user interaction or rely on certain data points to be true in order to actually do something. An example of sort of a high level how conditionals would be used is going back to like authenticating users. If you require a username from the user and the user doesn't type the username in, it should give you back a warning message or an error message saying there's no username filled out. But if you did put a username, it should go through and run the authentication. It doesn't make any sense to try to run authentication on something if the user hasn't given you the username. So that is sort of a high level look at conditionals. Now let's look at how conditionals are done in Python. So similar to how we create functions, we have the keyword if, condition. Now this condition again is the Boolean expression. It needs to return or it needs to have a true or false value. So if this is true or false, well in this case if it has to be true, so if this condition right here is a true Boolean value, and then we have this colon again, Now, whenever you have this colon, you remember you have to have an indentation here. So you have to have this block of indentation. You would want to do something. Else, do something else. So if this condition is true, it's going to run whatever code is in this code block here. Otherwise, it's going to run something else. So let's go back to our example. And kind of show you how this conditional is done. So I'm just going to use my my current example that we've had. So we have this money in second account, and has enough money, excuse me. So I'm gonna run this code again. So I'm gonna say has enough money is equal to money in account is greater than or equal to the total. Right? I'm just going to redo that expression. Now what I can do is I could say if has enough money. So I'm just checking the first account. Remember, I only use this first account. If has enough money. And remember, since this is now expecting us to have a block, we have to indent this in. So we can either do, in this case, we'll do 2 spaces. I can say print, sorry, you do not have sufficient funds. Enter. Else, print. Oh, whoops. I did it the wrong way. I'm sorry. Let me do that again. Sorry. If has enough money. I did it the opposite way, excuse me. Because if you have enough money, you don't want to get an output saying you don't have enough money. So print congrats. You have enough money to make this purchase. Right. We'll just be very ecstatic with our messages. Else, print, sorry, you do not have sufficient funds. Okay. So you can tell right here that we have a similar block to what I showed you on the notes. So now if I hit enter, you'll see that I get a printout, sorry, you do not have sufficient funds. But I didn't get this printout of congrats, you have enough money. That's because, obviously, because our Boolean value here is false, it runs this block of code instead of this one. So it's sort of that whole if this then that mentality, but you can see how powerful this is because now we can write code to handle multiple cases rather than just one specific case. And if you think about this in a sense of like we're writing a specific code for like an e-commerce site and we need to like run the funds and we need to check to see if they have enough funds in their bank account, we can do this check, and this print, you can think of it as being like an error message or a confirmation message to the user. Now, you're probably thinking, okay, that's cool. We can do like sort of a fork in the road. You can go this way or that way. But what if I have more cases? Well, that's great because you can actually handle multiple cases, which is if you look here, there's another keyword called elif, which is like a smushed version of else if. And pretty much what we can do is in between the if and the else statements here, we can say elif another condition is met, then we could do something else. So this basically gives you another path to do something different if you want to handle multiple cases. So another way to think about this is going back to thinking about how to authenticate a user. I said if they didn't give you a username, then you should just error out. But what if they gave you a bad username, something that didn't exist? You should still attempt to authenticate it because it could be a username, but if it doesn't work, you should still give some type of error message. So this is another example of how you can do multiple cases. So let's go and show you how that works. Okay. So going back in, right? I said has enough money. I created that variable. So if I said if has enough money, print congrats, you have enough money to make this purchase, right? Now I can also say elif, and in here instead of just putting a variable, I'm gonna put the actual Boolean expression. So I could say if money in second account is greater than or equal to the total, print you have enough money in your second account to make this purchase. And then else, we're gonna go back and do our other statement. Sorry, not enough funds, right? So if I hit this, now if you look at the printout of what I had, I didn't fall into this block like I did previously. That's because I added this other else if to check my second account to see if I have enough funds. And if I don't have enough funds in that one, then I can finally say, no, sorry, you don't have enough. So you can assume that this is something where I have multiple bank accounts and I need to check all the bank accounts to see if I have enough to pay off a debt or pay off a purchase, right? So in this case, I checked my first account, and if my first account had enough money, then I can confirm my first account had enough money. Otherwise, if my second account can pay that total, then I print a confirmation that it paid the second, or I can use my second account. Otherwise, just say you don't have enough funds. Now, we could just get rid of, you know, another way we can do conditionals is we can just say if something. We don't need this else. Similar to how we didn't need this elif, we could just say if has enough money, print has enough money. And you see nothing happens. So you can also run conditionals where you can just check to see if something's there, and if it's not, if some value is true, and if it's not true, then don't run this set of code. So you have those options. You can, and the great thing is with this elif, you can do this as many times as you want. You can handle as many cases as you need to check whatever things you need to check or to run whatever code you need to run. That is basically the hour. I don't want to go over the hour. I'm trying to keep things consistent. So if you don't fully understand some of these concepts, feel free to pop in on the Discord or pop in on comment on the YouTube channel or whatever. And I'll be more than happy to kind of prep up some more examples or explanations about this concept. But we went through a lot today. We went through Booleans and Boolean operations, logical operations, and and a little bit about conditionals. So just like sort of this if and else. Again, I'm only going through sort of the basics enough for you to kind of understand the concept. It's okay if you don't fully understand how to use it in coding yourself, because we will later on be doing real world examples on how all this kind of applies together. But I want to build a foundation first of understanding these core concepts, because I don't expect you to have any coding knowledge. I just want you to be able to have the foundations to just key buzzwords that you kind of can see and things that kind of hint on you, and then we can build real world examples and show you how these things are done, and sort of let you get your hands dirty and get coding and stuff like that. So again, I post all of the VODs on YouTube. So here's our YouTube channel. I also post we have our Discord. So if you have any questions about Python, even if it's something that I haven't talked about, I'll be more than happy to answer. But that's it for today's session. I will post the VOD on YouTube tomorrow, and our schedule is every Tuesday and Thursday at 5 p.m. Pacific. We will go live and do an hour of coding. Right now, we're still just kind of getting off the ground and doing a lot of the basic stuff, but we will get into much more in-depth stuff after we've built that foundation that people can kind of go through. So thank you to those who tuned in and checked it out. If you have any questions, let me know. Message me on Twitch or Discord or whatever. And we will be on Thursday, and we will go through more about conditionals and do more examples on conditionals. And then I'll go back and kind of do a roundabout on modules, because I know that was a little bit confusing. Even to me, I just kind of winged it. So I'm going to create more information on modules, and even start getting into some of the Python modules and how we can use some of that stuff too. So we'll get that tuned in for Thursday. Thanks for tuning in, and I'll see you later.